Okay, so now we're going to go on to proof number 2 for April 2nd, 2020. In this proof, we are given this, again, quadrilateral ABCD. And we can see that it has two diagonals. What we know from the given is that these two are congruent and they intersect at E. And then we've got these two angles right here are also congruent to one another. What we are told also is that right here, BD is perpendicular to AC. What we're trying to prove is that this quadrilateral is a rhombus. Now, to go ahead and prove that this is a rhombus, you're required to find out that all the sides are congruent to one another. Okay, now that we know what we're trying to do, first thing that should hopefully come to mind is the fact that you can prove triangles congruent to one another. That's one way, and then use CP/CTC to say that their corresponding parts are also congruent. Another method to go about doing this is by the perpendicular bisector converse theorem for only one part of this problem, which says that since BD is a perpendicular bisector to AC, then point B, since it lies on that perpendicular bisector, must be equidistant to both endpoints of segment AC. That's one part that we have proven so far. Now, if I can go ahead and prove that AB is congruent to AD somehow, then I've got three sides congruent to one another. And if I repeat that method again, I can prove that CD is also congruent to the other three sides, therefore making this quadrilateral a rhombus. So again, let me go over this one more time. We know that AB is congruent to BC because of the perpendicular segment bisector converse theorem, which says if a point lies on the perpendicular bisector of a line segment, that point must be equidistant to both endpoints of that segment being bisected, which is AC, therefore making AB congruent to BC. I'm going to go ahead and move on to proving these two are congruent. AB is congruent to AD. One quick method that comes to mind is to go ahead and use the fact that these two triangles are congruent by AAS. Since ADE as an angle is congruent to ABE because it's given, and ADB and AEB are both right angles because of the definition of perpendicular line segments or lines, and I know that they share AE by reflexive property, it's congruent to itself, then these two triangles, AEB and triangle AED, are congruent by AAS. So I'm going to go ahead and say since these two triangles are congruent, then by CP/CTC, AD must be congruent to its corresponding side AB. Now that I have three sides congruent to one another, I can go back and use the same exact original method that I used to prove AB congruent to CB and say, well, D also falls on the perpendicular bisector of AC. And by the converse theorem of the perpendicular bisector, we can go ahead and say point D must be equidistant to AC, which makes AD congruent to CD as well. Now, as you can see, I have four sides in this given quadrilateral ABCD congruent to one another, which is all it takes to say that this quadrilateral can now be classified as a rhombus by definition of rhombus.